Hello everyone, welcome back. So let's try out a few more example problems. So this is example 4.7. We got a simple beam. We're going to calculate the reactions at each support. Okay, simple beam is a parallel force system, which is nice. That saves us from having to do all those components. You won't always get that, but at least you do today. And you see we have a pin support right here and a rolling support. What's a pin support do? Well, if I replace that, I'm going to get a vertical force and a horizontal force. Why did I draw these up and to the right? I did that simply because that's what I usually set positive as. You can do it any direction you want, and if you draw it in the wrong direction, then you'll just get a negative number and you'll be able to switch your arrow and switch your sign. But in this case, you see all the forces are pointing down. It kind of makes sense that this force should be pointing up. Similarly, for a roller, I only get one force, and that force is perpendicular to the ground that the roller is on, so straight up in this case. If it was on an angled surface, it would be perpendicular to that surface, so be very careful about that. So how am I going to analyze this? Well, draw a free body diagram, and I've more or less already done that. I'm going to establish some equations of equilibrium. I have three, which is my forces in the horizontal or x direction, my forces in the vertical or y direction, and some of the moments about a particular point. I only get to do that one time per free body diagram. Okay? You have three equations and that's it. If you're like, well, why don't I just do it here and then here and then here? In the end, all those equations that you're doing will just turn into one of these three equations. They'll just simplify to them. So you only get three equations that are different. And so by following these steps, we should be able to solve. So let's try it out. First, gotta draw that free body diagram. So I've done so. Now I've replaced the supports with reaction forces. And I went ahead and got rid of the beam and just turned into a line. All my distances are here. It's looking good. Because I only have one reaction force for the roller and two for the pin support, though one of them is already marked as 0. Now we're going to establish equations of equilibrium for the left end of the beam. So I'm taking some of the moments around point A. Now, why am I doing it around point A? There's lots of points I could have done it around, but the big thing is this. I hate algebra. Say it with me. We hate algebra. So let's avoid algebra. And you know how you avoid algebra? You get rid of as many unknowns as possible, so hopefully you only have one unknown. Now, when I take the sum of the moments around a particular point, any force acting on that point does not cause a moment. It doesn't even exist inside of that equation. So when I do sum of the moments around point A, the distance is 0 for both of those forces, so they don't even show up, which means I have one unknown. That's it. So if I'm careful and I plug in all the forces, as well as all their perpendicular distance, these are all vertical forces, so their distance is always going to be the horizontal. For each of them. And I'm very, very careful. The direction of the force does not matter when you're taking this in the moments. Just forget that it's pointing it down and up. Think to yourself, does it make it go clockwise? Okay, all those are going clockwise. But then one of them is going counterclockwise. So you have to decide which one's going to be positive, which one's going to be negative. In this case, I said that counterclockwise was positive, and each of these is therefore negative. Okay? That is probably the easiest way to tell what direction, which one is positive, which one is negative. Just choose a direction, counterclockwise or clockwise, and then just draw this line. You're going to go up and then fall down on it. Up and then fall down on it. Up. You see how it's going? So all those are turning it clockwise. This one's turning it counterclockwise. So with that, we can solve it. And what do we get? Well, we get that our reaction force at B is 2,892 pounds. I'll let you plug that in your calculator. Be very careful with it, and you should get the same answer. Now that we have that, it's time to figure out what reaction forces at A are. Now we already know what B is. There's two other equations I can use. So now I'm going to use some of the forces in the vertical direction. I choose that one because, well, there's only one unknown in the vertical direction. This one's not in the vertical direction, so it doesn't count. So I have one equation, one unknown. I don't have to do any algebra. I just get to go for it. Now, this is the point where direction does matter. You have to decide what direction is going to be positive. I choose up as positive typically. And so this is positive, and all of these forces are negative. This is also positive. So once I have that, I can get the vertical force at point A, which would be 1,908 pounds. That's just me plugging it in and saying, okay, I'm going to add this force, and 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 this force. And I know that they all add up to 0. They have to, otherwise this is moving. If they don't add to 0, it's going to move. Now the last question for you is, why is that marked as 0? Whoop. Why is that one marked as 0? Think to yourself. Everything, all the forces have to sum to 0. Do you see any other forces pointing in the horizontal direction? Do you see like a force over here? Or a force kind of going diagonal or something? Anything that has a horizontal component? You don't. So this one has to be 0, otherwise this guy would be accelerating that way. We don't want that. We want it to stay stationary. So since there's nothing to combat it, the only way we can actually still be in equilibrium is for it to have 0 force. So don't be confused. Sometimes you will have reaction forces that you drew that are 0, that actually don't have any force coming through those. That's completely fine. That is normal. Just be expecting it. So thank you very much for listening, and I'll see you all next time. Bye-bye.